All right, I think it's 11:30, so I'll go ahead and get started. If you don't know why you're here, hopefully you're here because you want to hear about the Kubernetes CRI interface, so how it talks to container runtimes. And specifically, first half I'll talk about the CRI and runtimes. Second half, I'll try and demonstrate and make it practical by showing Containerd as a runtime for Kubernetes. The fun part of this demo is we're going to talk to my Kubernetes cluster back in Dallas, Texas in IBM Cloud over my phone's 4G connection. So the demo my commands may be slow enough that we can talk through that and answer questions as we go. So let's get started. I'm Phil Estes. I work for IBM. I'm a distinguished engineer in our cloud platform unit. More importantly to this topic, I've been contributing to container runtimes for about 4 years, starting with Docker and the whole Docker ecosystem, and then in the last couple of years, Containerd. I'm a maintainer in Containerd, as well as we have a few others here. In fact, if you're unhappy with how deep I get into Containerd, you have another chance today at 3:05. Derek is over here on the far corner of the room. Derek and Mike Brown. Mike Brown is also from IBM and a maintainer in the CRI plugin. They're going to take you on a deep dive of the whole Containerd architecture. So again, you have a couple chances to hear more today about that. So you're at KubeCon Shanghai, the very first Cloud Native and KubeCon on the continent. And so maybe it's silly to ask, are you using Kubernetes? Maybe you're not yet, but you're interested or you're learning this week about it. And the important thing to note is that Kubernetes is really just that orchestration platform above a container runtime. And that's important because Kubernetes doesn't actually run your containers. So there's no code. If you look through the entire GitHub repo for Kubernetes, you will not find any code that knows how to start a container on a Linux or Windows system to handle the lifecycle commands of creating, starting, stopping containers. For many years that's been done. That role has been played by the Docker engine. Again, you can look back. This URL here is to release 1.4 of Kubernetes. So, ancient history if you're keeping up with Kubernetes 1.11, 1.12. But, pick an old release, you'll find a package called Docker shim in Kubernetes. And the Docker shim was implemented to know how to talk to the Docker engine and have it do commands like Docker run, Docker start on behalf of Kubernetes as it created pods, as it created put your application orchestrated across a cluster. So again, that's kind of been the life cycle of Kubernetes. Again, I don't have a lot of time to go into how Docker itself has grown and matured over the last few years to really be a stack of components with the Open Container Initiative's Runc at the bottom of that stack, Containerd, a CNCF project, as you know, and Docker driving those. So again, that's been kind of the way things are for a good while. But back in 2016, and actually we're coming up on 2 years since this blog post came out on Kubernetes, on the Kubernetes blog about, hey, we're introducing a container runtime interface to abstract the Kubernetes code base from runtimes like Docker. At this point, Rocket, also a CNCF project, had a variant of Kubernetes called RocketNetes, where you could drive Rocket as the container runtime. But as the Kubernetes community tried to figure out what to do with the fact that now you had places all across the Kubernetes code base that had to know about the runtime. And that got very messy. And if you thought about adding a third or a fourth or another runtime, the CRI was meant to separate those concerns. So anyone could implement the CRI API, and you could become a container runtime underneath Kubernetes. This is a rough differentiation between the role of what Kubernetes still has to do, and then the CRI interface effectively separating out what the container runtime's job is underneath Kubernetes. This picture isn't perfect. I've gotten feedback from a few other talks that, there's obviously ways in which some of these roles are handled on both sides of the CRI, but it gives you a general idea that Kubernetes is still handling the Kubernetes API, it's handling storage concerns, you've picked a CNI plugin to handle your networking, Kubernetes, all the API machinery around health checking and placement, all the orchestration parts of Kubernetes, all that is still handled by Kubernetes. On this, when it wants to place a container on a node via the kubelet, obviously the things on the right are things that your container runtime is going to have to implement that are part of the container runtime interface, such as all the lifecycle commands that you'd expect: start, stop, delete. Also image management. So your container runtime is going to have to talk to registries, pull images. Actually, push is not correct. You don't push images from a pod. Get the status of an image. Is it pulled? Get all the layers, pod status, and all the related parts of knowing the state of your pods and containers within them. And then there's a bunch of things you can do from the Kubernetes interface side, like I want to exec into a container, I want to attach, I want to assign a port, I want to get logs. All those interactions have to be implemented by your container runtime via the CRI, so that when those Kubernetes APIs are called, your container runtime can handle the runtime aspect of those operations. So again, that gives you a basic idea of whose job is what in the Kubernetes world between the runtime and the Kubernetes stack. So now that we have the CRI, you might think, well, who's implemented this API? What runtimes are available underneath Kubernetes? Obviously, Docker Shim has been repurposed to implement the CRI. And so many clusters today, many production clusters continue to use Docker as the runtime. Obviously with Containerd, the project I'm associated with, we have a CRI implementation that handles the CRI API and then calls into Containerd to, again, do all those runtime steps for the CRI. Who's heard of CRI-O from Red Hat? So CRI-O is a project that also implements the CRI, and basically CRI-O has all the code to drive runc directly. So again, runc is underneath both Docker and Containerd, but CRI-O is a wrapper on runc to again implement the CRI. And then Fracty is a shim implementation. Initially, Hyper.sh and Intel Clear Containers both had lightweight virtualization capabilities. So this shim could basically either do lightweight virtualization like through runv, or call the Docker engine when you didn't want to use lightweight virtualization. But if we fast forward to today, a lot of that is now handled in the merged projects of Kata containers, which I think you've probably heard about a little bit this week already. And not only is Kata associated with Fracty, but they're working with both CRI-O and with our team in Containerd so that you can actually use Kata containers on other runtimes as well. Again, the kubelet has ways to specify which runtime do I want to use. The tools that you use to install your Kubernetes cluster may allow you to factor this out. And we'll talk about who's using Containerd and making that possible. But at this point, you might ask, well, I'm just a Kubernetes, end user. Why do I care what runtime is at the sort of bottom of the stack handling running my containers? And it's true that most of the benefits of being able to plug in different runtimes is operational more than end user focused. So your kubectl commands don't change depending on what runtime, and so your application developer and And the people at that end of your development organization probably don't care if Docker or Containerd or CRI-O or Kata containers is running the containers at the bottom, but operationally there may be benefits. So I cheated and took one of Kelsey Hightower's tweets where he said, treating containers like a black box will eventually leave you in the dark. And I hacked it to say, treating container runtimes like a black box will eventually leave you in the dark. I haven't officially gotten his approval that the sense of the tweet still stands, but what I mean by this is that even as an application developer or someone at a higher layer of the stack, knowing what container runtime is there and what its capabilities are and how to interact with it can be valuable. And definitely to your operational team, there may be benefits to Containerd or CRI-O or Docker, depending on other needs of your environment. So for, just to hypothetically, talk about what would you need from a container runtime, you probably are going to care about performance. You've heard in the keynotes all the interesting workloads that people are placing on top of Kubernetes. Everything from AI to genomic sequencing they were talking about this morning. Maybe you have security concerns. Maybe you're running untrusted workloads, and so the hypervisor isolation of Kata is very interesting to you, or maybe you're interested in gvisor or other interesting isolation capabilities. So maybe the runtime you choose, you want to make sure it has those options. Maybe you care about multi-architecture support. So at IBM, we have Power Systems, we have Z Systems, and so making sure that my container runtime operates in those environments. Maybe you're in the IoT space and you have ARM devices or other CPU enablement that you want to make sure your container runtime has those capabilities. So again, those are things you might think about if you were deciding what runtime do I want my Kubernetes cluster to use. So let me talk a little bit more about Containerd. I don't have enough time in the session to really dig deep, but as I mentioned at the beginning, and some people have showed up, so I'll mention it again, later this afternoon at 3:05, there's a deep dive on Containerd, on its architecture that will go into more depth than I can. But effectively, over the last few years, Docker has contributed code that used to be part of the monolithic Docker code base to various open source foundations. So you have Runc, which is that basic unit of simply executing containers, mostly thinking in a Linux kernel interface environment. So how are the namespaces and C groups and everything set up? That's what Runc is doing for you. Containerd has been donated to the Cloud Native Computing Foundation. So again, you've seen Containerd as a component of the many projects within the CNCF. It sits on top of Runc and basically manages those Runc processes for you. And then in our recent releases under the CNCF has image management. So we can push and pull from registries. It fully supports OCI. It has a great client API, so we're finding many users who love Containerd as a way to be embedded into other runtimes or other software systems. And so Alibaba's Pouch Container is also a user of Containerd. And so on top of that, you can obviously build other software stacks. So the Docker engine, Docker CE, Docker for Mac, Docker Enterprise, they all use Containerd and Runc. Kubernetes via the CRI can use the same stack. Docker Swarm and their orchestration can use the same stack. And so we see Containerd as really that core container runtime for the cloud. Again, some of the benefits, these are just highlights, not really a deep dive, but really we intended for Containerd to have broad usage in the industry. So projects like LinuxKit and Kubernetes, Cloud Foundry, some of the other use cases I mentioned, we expect that Containerd, because of a good client API, stability, performance, can be used by many, many projects as a great container runtime. We've also spent a lot of time doing stress testing, making sure that Containerd is stable, that we can meet its performance criteria. And so Michael Crosby, one of the key contributors and maintainers on Containerd, tweeted earlier this year that we have a 24/7 system that's just constantly starting, stopping, execing all the lifecycle operations into Containerd and running millions of containers every week just to continue testing and making sure that every change that gets checked in, we haven't impacted the stability or performance of Containerd. And again, another aspect of what we've done with our commitment to stability is also a stable API and stable releases with very specific support guarantees. And so we do bug fix releases, we do backports of bug fixes into old releases. And so again, that's just part of what we hope is a viable platform on which other people can build their products and software. This was announced yesterday morning. Liz Rice mentioned that between Copenhagen and this event, that Containerd integration into Kubernetes was announced as GA in May. That was actually around the time frame of KubeCon in Copenhagen. But again, just a validation that the implementation of the CRI and integration into Containerd is viable for use cases, production use cases in your cloud or in your software platform. So based on that, who is using Containerd today? Obviously, one of the interesting places that you can go hear a lot more about Containerd being used is Kelsey Hightower's Kubernetes the Hard Way uses in all the examples Containerd as the runtime. We have 2 public clouds that are currently using Containerd in sort of early preview. IBM Cloud's Kubernetes service has Containerd if you select Kubernetes 1.11 or 1.12 as your cluster. You automatically get Containerd as the runtime. And then down below that, that's the Google Kubernetes Engine logo. They have in beta today, you can select Containerd as the runtime in a GKE cluster. Again, every version of Docker for the last few years uses Containerd. So every time you install Docker, you're also getting Containerd. Linux Kit, which is a project that builds Linux distributions, purpose-optimized Linux, also uses Containerd. Rancher has a project using Containerd. Kata has been a big proponent of Containerd in our new V2 shim that maybe you can hear more about if you go to the deep dive today. I mentioned Alibaba's Pouch Container. And there's a couple IoT projects, Belina and Elliot, that are using Containerd. And the Cloud Foundry Container Runtime was using Runc, and they're now switching to Containerd as well. So again, the purpose of making sure that Containerd was viable for many use cases, we feel like we're seeing that come to fruition with a lot of users, a lot of people building on top of Containerd and finding it valuable for their model of needing a container runtime. So effectively, the rest of the time, so we have just about 15 minutes, I'd like to demonstrate kind of these layers. And before I do that, I thought it'd be useful, I'm going to show you my cluster setup in a minute. But this picture may help to describe what I'm going to try and show, especially if it doesn't go well, at least you'll step away with an understanding of what I was trying to show. So really, now that we're talking about Kubernetes having the CRI and a container runtime, you can think about talking about the workloads on your node from 3 aspects. One is the kubectl commands, which is you talking to the Kubernetes API. So I'm going to use the client, the standard client. So we can think about a command like kubectl get pods. And so that asks the Kubernetes API, list my pods. If we go down to the CRI layer, there's a nice tool, CRI-ctl, that interacts with the CRI API directly. And so I can do a very similar thing with CRI-ctl. If I'm sitting on the host node where the kubelet is running, I can use CRI-ctl to talk to that CRI API and say, hey, tell me what pods are running. Well, now if Containerd is my runtime underneath Kubernetes, I can now use the CTR tool, which is Containerd's simple client. And I can say, Containerd, hey, tell me what containers are running. Because obviously that should match to the pods and the containers running inside there. So I'm going to do a few examples using these three commands. Because of time, I'm not going to show you how the shims actually drive runc, because runc even has a client where we could potentially ls and look at runc processes on the host. But for the interest of time, let's see what we can accomplish here. So again, I did say I would show you my cluster. So I have a Kubernetes 1.11.3 base cluster in IBM Cloud's Dallas 12 region. I have 3 worker nodes. The IBM Managed Kubernetes service is handling the master node. I don't have to worry about that, but my worker nodes are running Kubernetes 1.11.3. And so I've already, for the interest of time, deployed a few things out there. So I have some pods that are already running on this node. And if I switch to my secret little method of getting onto the, so now you can see I'm on W2, which is worker 2. So if I go back to this other picture, that should match this, the middle entry here, a certain public IP. That's the actual node I'm SSH'd into. And so, obviously, if I'm right about this cluster running Containerd, I should see that PS looking for a Docker process. There's nothing on the system running Docker. Obviously, if I use the CTR tool and just ask for a version, I can see that I'm running Containerd 1.1.4, which is our latest release on the 1.1 line. And it actually was able to connect to the server, also running 1.1.4. And so you can see this is a worker node within my Kubernetes cluster running Containerd. And if like I said, I can talk to the CRI with CRI-supporting. And I'm sorry that I made the text big, so hopefully everyone can read it, but that makes the output not quite as pretty. But these are obviously the list of pods that are running. There are many pods because there's obviously many namespaces, so IBM and kubesystem, and I have Istio deployed here. It's a huge list of pods. But because in this other window, you can see I have this my-nginx running, and there's 4 of them, and I only have 3 nodes, so I should at least have 1 pod on this node. And so let's see if I can find that here. If I CRI-supporting pods and grep my nginx, sure enough, it's down here at the bottom. I have the TV47Q pod. So if we go back and look at the pods, that looks like the very last one here, the my-nginx. So that pod is running on my worker 2 node. And CRI-supporting, I've been able to use, I've seen from kubectl, it's told me that these pods exist. I've gone to one of my worker nodes, and now I'm talking to the CRI socket, and I've asked it to tell me the pods, and sure enough, my nginx pod is here. Well, now let's go down to Containerd and see if I can find, this pod, because at some point that should turn into an actual container, and we can see the container running on the system via Containerd. I think I already exported. So another thing that maybe you'll learn about if you go to the deep dive, actually I don't have it set here. So Containerd supports namespaces, which means you can actually use Containerd by multiple kind of higher layer users, including, actually if I go to my laptop here, you can see that if I talk to the CTR, So my laptop is running Docker 1809 that just came out last week. If I ask the CTR on my laptop, what namespaces do you have? You'll see K8s.io and Moby. So now that Docker is using my system container D, it's creating containers inside the Moby namespace. If I had a kubelet running on my laptop, it would use the K8s.io namespace. And so if I go back to this worker node and do CTR namespaces ls, you can see I only have a K8s.io. I don't have Docker running here. I don't have other users of container D. And so if I don't set a namespace and I ask container D to list containers, it gives me nothing. I actually have to tell it, no, I want to look at the K8s.io namespace. To save time typing, I'm going to export a variable namespace equals K8s.io. And now when I do CTR-CLS, I get a huge long, again, it's kind of ugly output because of the text size. But again, these are all the containers that container D knows about because, again, kubelet has talked to the CRI. It started pods, which started containers. And so this is representing that list. And so if I look for that Nginx container again, so I'm going to grep for Nginx, you'll see that here at the bottom, I have a long container ID, and you can see that the image being used is my little Nginx demo, and it's using the containerd v1 Linux runtime. And so again, we've mapped all the way from kubectl, get pods, so we saw that there were a bunch of Nginx pods. We asked the CRI to list pods. We saw that one of those pods is on this worker node, and now I've gotten all the way down to a container in container D is actually running the Nginx there. So the next thing I can do is I can actually, I can ask, actually I want to get that ID. Let me get that. So it starts 39605. If I copy this and then ask CTR to tell me the tasks that are running, which map to actual processes on my system, I can find that there's a PID 26977 that's actually running, and this matches that container, which matches that pod. And so unless I've got something disastrously wrong, if I ask the system to list processes and grep for that PID, it better be an Nginx process. And sure enough, well, it's got FCGI running and Nginx. So this is my actual containers process running Nginx. So again, we've gone all the way from kubectl listing pods to CRI-ctl, again, listing what pods are on this specific node, to a container, to a task, to an actual PID running that workload. We have a couple minutes left, so one thing that might be interesting is to think about how in this scenario we can start to see how Kubernetes and container runtimes interact. And so one thing I can do here, so basically this Nginx that's running, I can show it in the browser just so you get a sense for what we're doing here. If I hit, I've got this connected to Istio's ingress. All this Nginx container is doing is it returns the pod name, as the HTML response from a request for index.html. And so if I keep refreshing, I should, be hitting the various pods, and every once in a while you'll see it's actually hitting the pod on this node that I'm logged into, the TV47Q. So that's great. Kubernetes, load balancers, Istio, that's all doing magic to route traffic to my actual pods, which ends up at my actual containers. If I if I set up a little watch that this is just running that same, it's using curl to query the pods, and every once in a while it'll pop around and change to various pods. One thing we can do is we can actually kill the Nginx container on this node. Now I'm not going to stop the pod, I'm just going to kill the container using container D. And let me see if I remember how to do all this right. Actually, I need that ID. Does everyone remember, Derek, do you remember the signal? Is it -S? Let's try this. Let's have fun. I think okay. So if that worked, I should no longer have, I'll still have a container, but I shouldn't have, let me look for Nginx again. You'll see that it started a new one on this node here. And so what shouldn't have happened is we should still have a pod named TV47Q, because I didn't actually kill the pod, I killed the container, and it can recover from that by just restarting the container. But now, so again, we can step back up to CRI. So now we could use CRI-cuttle. This is where I haven't memorized all the commands, so this will be fun. I think it's stop P. Oh, I need the ID, don't I? So I'm going to get the pods. So here's the pod ID. I'm going to copy that. So CRI-cuttle stop pod. Stop P is stop pod. And CRI-cuttle remove pod, same one. If I did it right, so you can see that it stopped and removed the sandbox there. Actually, it'd be good at this point to kubectl get pods. I'm probably not fast enough to actually see the container. I must have done that wrong because I still have a pod, don't I? Named TV47Q. Either that or the yeah, I definitely deleted the pod. So it's interesting. We should have seen in kubectl, we should have seen a failure in kubectl get pods, and then a restart. I think we're almost at time. We only have a couple minutes, so I think rather than investigate why I didn't get to show you that properly, let's just switch back to the charts for a second, and we'll finish up. So again, there's a great, so if you're going to use CRI and CRI runtimes, there's a great user's guide for CRI-cuttle, all the things you can do. I showed almost nothing of all the possible things you could do with CRI-cuttle. You can even create pods. You can have an OCI spec and start and stop pods from CRI-cuttle. There's a great talk from KubeCon in Copenhagen, doing some more. He had a little more time, so you could do interesting things like actually replace the runtime underneath the kubelet. You could actually switch from Docker to Containerd and back and show that the pods kind of restart and continue running. We have lots more information at our GitHub project page, and I should be adding our website because we have a new website, containerd.io, that also has a lot of great information. So with that, I say thank you and say please go see Derek and Mike's deep dive if you're interested in more about Containerd and the architecture later today. And you can find me online or send me an email if you have more questions. And I think we're effectively all out of time. I'll pack up and be available here if you want to chat, but I'll make room for the next speaker. So thank you very much.